Hello everyone, my name is Jason. I'm honored to be speaking the topic of the Bring LLMs Home today. To briefly introduce myself, I've been working as a technology mentor at Apple Developer Academy in South Korea for past 3 years. And also, I'm also a PhD candidate at this moment. Before joining this academy, I built my career in networks and the machine learning related companies. I'm great to be here with all of you guys. Here is today's agenda. In this first part, I'd like to share some key topics related to AI that we should all reflect on together. This session is designed for everyone to easy to follow. In the second part, I'm going to discuss about strategy and the methods for integrating AI into your services or devices. Even if you're not familiar with the machine learning, you will gain some insights into the AI tools and also resources provided by Apple. Okay, next, to be honest, on third part, it's gonna be a little bit challenging, not gonna lie, but for those who knew the machine learning. But however, I've distilled the key points to make it as clear as possible. So let me cover the features and precautions of Apple core ML tools with useful tips on integrating LLM effectively. Okay, so let's dive into the first part. So before we discuss about open source model quantization, I'd like to start with this story. Yeah, as you guys know, a few weeks ago, a huge whale named DeepSeek shook in the AI industry, right? So this event has a significant impact on all the companies involved in Gen AI, and NVIDIA took the biggest financial hit in one single day, right, in history, ever, right? Why did it happen? Because the training LLM usually requires a high computational power, right? But like many companies have long wanted to break free from their reliance on NVIDIA's GPU. They try to get out of it, right? And there's multiple reasons why DeepSeek is so special, but its true value lies on the adoption of the new paradigm that challenges the conventional approaches. Okay, so as you know, LLM stands for large language model, right? But the real shift happening in AI development is not making model larger and bigger and heavier. Instead, the industry has been moving toward making the models smaller, faster, and more efficient. So fundamentally, like reshaping the AI competition landscape, right? So traditional approaches relies on techniques like logical distillation, quantization, pruning, stuff like that. Those methods are like essentially like reduction of the resolution of the model, right? And the traditional model compression techniques involves the first training large-scale model, and then compression is knowledge, squeezing it, and into the smaller model. This approach requires significant resources, cost, and the initial model training. DeepSeek R1 family takes different approaches. They leverage the reinforcement learning for self-supervised reasoning and utilize the efficient architecture with MOE, which stands for the mixture of experts, optimize attention mechanism, and this allows them to train the model cost efficiently. You know, like it's not like post-training or like quantization; they just born different, right? So from the start, as a result, the DeepSeek's method is significantly more effective and more efficient in terms of both training costs and computational resources. So does it mean like we just accept those kind of like cost efficient models as they are? The answer could be yes or no. It depends on your situation, right? So there's the Korean slang, 마른 수건 물자기, which means it's like squeezing water from the dry towel. It's in other words, the pushing optimization to the absolute limit. You know, like as we engineers, like we must keep questioning and refining our approaches. For example, take a look at the bird. How much, no matter like how much we mess up with it, like its identity it still remains as a bird, right? This is the essence of the challenge. Like how can we make the LLMs lighter, but meanwhile at the same time maintain the performance and at the same time the inference quality. Okay, this is why in the part 3, today's keynote, I'm going to demonstrate the quantize and optimize Llama 3.2, 3 billion model, to improve performance and then reduce the size. Along the way, I'm going to share the insights discovered during the process. Okay, so but before we dive in, like we need to understand Apple's machine learning ecosystem first. So when you think of the machine learning ecosystem, what comes to your mind first? Like, like Apple's like 5 years behind the Google. Like some people probably think like that way, right? But we do have a different agenda, different vision. So it's a different story. So there's some key factors. Some may look familiar, some maybe not to you guys. But Apple's machine learning ecosystem consists of various frameworks and APIs. If you feel like this is too much to you guys, don't worry about it. Because the world has changed for better. So we have access to not only first-party frameworks and the libraries, and also third-party resources, the community-driven services. For example, like the Hugging Face has fostered enormous community where the knowledge is actively shared, and that we can always discuss the challenges together, right? So beyond the first-party tools, there is a vast ecosystem of the deep learning resources available in it. It's time to break down barriers and embrace these achievements and advancements on open mind. Okay, so let's start with the easiest and the most accessible Apple first-party frameworks of Vision. Like, how many of you guys has used frameworks before? There's 5 different frameworks, right? Ever used before? Okay, some of them. Okay, so there's the image classification, like object detection, like the body pose detection, contour detection, like even like animal recognition and so on. There's so many. All of these capabilities are already available to use, right? And it's not, just as part of it. Like we have a vision and natural languages, and speech, and sound analysis and translation. In particular, the translation API has received a significant amount of updates recently. So what about the AI ML? So let's focus on the key highlights for AI ML advancements. So when Apple announced AI ML, many of you guys might have come across this flow diagram, right? I'm not gonna go over everything, but like just the point. This flow diagram condenses a lot of information into clear and structured flow. But for today's topic, I just want to highlight the one keynote, orchestration and the models. Okay, so at the core of it, the system must decide whether, sorry, I'm back. Okay. At the core of it, the system must decide whether they handle the user request on-device model, either on-device or the server model, right? And then Apple prioritizes privacy by processing as many requests as possible with on-device model first. They prioritize that. And then if there is like advanced user request, like something complicated one, and then it relies on PCC. So it stands for Private Cloud Compute, which is Apple's proprietary cloud solution. In those cases, user requests sent to Apple's server model, right, at that time. And then for those who are curious about the server model and foundation model operation, I highly recommend checking out this the machine learning research website from Apple. And this research paper provides detailed explanation from foundation principle to the benchmarking. Okay, so now the security is very critical for PCC, especially as this update involves handling user data on servers. The key concern is how can personal data encoded and decoded and securely processed? How can we trust them, right? The PCC is a SOTA, in the state of the art. It's the best security system for cloud AI processing, in the world, right? And even Apple employees cannot. They're not able to, access the sensitive user data. They cannot, right? So, Apple has not disclosed its design principle, and then this is the background. I recommend to check out the paper at this website, Security Research Division, and you can get a lot of information. And now let's continue the discussion about the on-device model. So how can we effectively and efficiently apply our on-device model? Okay, so in fact, Apple has long provided first-party tools for the utilizing machine learning model on device. So for example, we have a Create ML, right? It's really easy to we can make it models, right? But you can access different types of templates to create a vision or natural language. There's 15 templates exist, including the additionally we do have the recent WWDC. They also created they also added the object tracking one. right? So Apple introduced the object tracking template designed for spatial computing. For those who are interested in a Vision OS development, I highly recommend to watching the Minji Lee's speech from the last year, Let's Vision OS conference. You can ask your question, right? And then please don't forget to subscribe to the Let's Vision the YouTube channel. You can get a lot of information out of it. Also, okay, now, so once you create the core ML model, and then you can seamlessly integrate it into your app, right, using your core ML library. So most templates are used pre-configured transfer learning, so you can make the models very easily and very fast. Okay, but there's an issue. It's not enough, right? Probably some of you guys probably tried one of these the natural language related model, and then probably somewhat the performance is disappointing, right? So that's where core ML tools comes in. Instead of just waiting for Apple to release a new template, we can convert the third-party machine learning model to fit your needs. So building model from the scratch is kind of sounds horrible, right? It's kind of difficult. We don't have time to learn everything from the scratch, right? But no worries, many models are already available at Hugging Face. Of course, not all of these, over 1 million models can be converted. I cannot guarantee you. We have to figure that out. But like, we still can get a lot of valuable insights from these already transferred into the iOS or macOS the formats. So Apple has already developed MLX. It's a tensor computation frameworks optimized for Apple Silicon. And if you visit Hugging Face's MLX community, this is huge. It's getting bigger. It's fire, right? So if you visit this website, you can find the discussion about optimizing and maintaining the model weights and for the efficient execution on the Apple devices. So once you convert the core ML models, this can be integrated into your solution, and then it sounds like everyone will be happy, right? I don't think so. Not yet. Just because we have multiple models does not mean we're going to be happy, because we might have some issues. Like, we're dealing with the multiple models, and the size of models is getting bigger, right? Optimized inference speed is getting slower, right? As a result, performance can degrade significantly. Those are issues. So this is where core ML tools come into play. So it mainly does the conversion optimization. I'm not going to explain everything for you today. So up until 2 years ago, core ML tools has not seen like major updates, but starting in 2023, significant improvements and its library has been updated, such as the polarization, like quantization, pruning. I'm going to explain in part 3. And yeah, additionally, after WWDC, Apple introduced a new optimization-related update. So, for example, like key value cache as a model state, this is now available for, this is supported from the macOS Sequoia onward. So this method is far more efficient than the traditional input-output based on key value caching. And I'm gonna show you how to use that later. For instance, let's skip this. And it's pretty amazing, like how core ML tools can do, right? So by the way, the core ML tools actually based on the Python library, not the Swift based. So since it's the year of the snake, why not get a little more comfortable with Python this year? You guys can have like both stack like Python and Swift. This is kind of essential. Okay, so finally, let's move on to the final part, the converting and optimization models for on-device integration. Yeah, hang on tight. Let's get started. Yeah, here's Llama 3.23 billion instruct model for converting and quantizing. If you're new to model conversion and feeling kind of overwhelmed right now, let me assure you, bring the Meta LLM home is way easier than bring the actual real llama into your home. How can I be so confident? I tried both last week actually. Yeah. On business trip in Indonesia, and I did I went to the park and to see that, and then I was working on the conversion for this conference, and then I tried, but that was way easier. So please don't be afraid. If I could do, you can do, right? So here's some key insights from the actual conversion processing. Okay, so first, here's some important thing. So make sure to check the recommended model device, your device memory, for inference and conversion. Inefficient memory can cause your kernel die, right? So it was not working on my Mac. So I'm using M3 with a 16 gigabyte, and then it was challenging. So I borrowed the Mac Studio from my company. It comes with a 72 GPU, core GPU, and 192 gigabytes. That's crazy, right? It's incredibly powerful. But it could be overspec, right? So you have to find the proper one, proper device for your situation and solution. That's like too much overspec. So, and then you find that, and then start with the create the project from the Jupyter, and the load ML model. You probably need a request token from the Hugging Face to access the open source model that you want to load the Hugging Face. Okay, and then it takes like about 2 hours, I remember, and access they're gonna get you permission, and after submitting your request, and then once you receive your access token, and then enter and download it, and yeah, and then downloading full model, it takes a long time, right? It's kind of, it's like at least like 3 billion model is gonna be, like at least a 6 gigabyte, right? So if you use 8 billion, it's gonna be 16 gigabytes. So I highly recommend saving it locally before the loading it. You can pull up the model later if you need. And the Hugging Face library provides a utility like a Llama for casual LM. So what does this casual model do is the key function here is to wrap the Llama model by removing key value caching and fixing the input size, and to make your conversion process easier. Okay, is to make it like a pure, like a demure. Okay, and the next thing is tracing. You got the trace step. This step fixes the input tensor size, and then to prepare the model for conversion. And you set the batch size and then context length, and then like you can perform the tracing. And you have to remember these steps. And now you can finally convert the model. And there is some important note. If you set the minimum target to the Mac 15 Sequoia, you can use it's a default setting. You can use the fused SDPA. SDPA stands for scaled up the production notation. It's like, you can just think of it's like the calculation method of the tensor. Okay, so it's gonna be applied automatically, and then you can use it from the Sequoia. And to explain this simply, the LM actually uses transformer, right? The transformer models use a SDPA, and if you see the left side, before the macOS 15, it was split into multiple separate operations, like like matrix multiplication, like addition or softmax. You have to each operation like ran as an independent GPU computation, okay, the one by one, and this leads to slower execution. But now we can use macOS onward. SDPA has been updated, right? It has been integrated. It's fused. It's merged all together. So it's a single kernel GPU they use, and then that's why it's a fused kernel, right? It's a fused. So in short, optimization significantly speeds up the execution. So you probably want to use this trick. And also, after applying SDPA optimization, and the core ML conversion generates the ML package. I tested the model prompting with the WatchGen AI, and then when evaluating LLM, you probably need to check this. Like to evaluate the large language model, we have to know about the TTFT and TPS, TTFT and TPS, It's time to the first token. When you punch the prompt, it takes a time, right? And you have to measure that, and then the TPS is the token per second. So it's literally like a speed, velocity, like how fast your model does, right? So those are like originally we had like about the 47 for TTFT, and then 1 TPS at that time. This is like basic model after the conversion, which is very slow. And then now, not just converting, we have to optimize and make it faster, right? Transformer model actually, the tensors are computed for each token, and the tensors are computed for each token, and every time the new token is added, the model must recalculate the query values. They do recalculate one by one for all the previous the key value pairs. And but like now, we can use the key value cache as a state, which means that by registering the key value cache inside the model, we can reuse the previous the computation result. So it makes it way faster. This improves the inference speed dramatically. In short, we can maintain the original model weights the leveraging the key value caching structure and as a part of the model state for the quantization. It has been like 47 for the TTFT to the ones just the less than 2 seconds, and then it increases 35 times for TPS. Okay, finally, so we apply 4-bit integer quantization. And here, we can apply block sparsity. I'm going to explain later, and then for the granularity. And then what it does is grouping 32 weights per blocks and to maintain accuracy while optimizing the model. Okay, so at last, I just want to show you all the flow before to explain the details. At last, we can export the fully optimized and quantized converting model. And then here's the final model. And then you can even quantize more and more. But you have to you have to calibrate. You have to find the proper moment to stop, right? And then otherwise your inference quality is gonna drop to the it's dropped so much. So as we expected, like we had we reduced the size like 4 times. Okay, now let's bring back our optimization table from the core ML tools. You have to keep in mind the optimization setting depends on your OS version. Yeah, default feature, the compatibility vary on iOS 18 and the Mac OS 15. So please pay attention to when you configuring your model. So now let's go over the 3 key optimization techniques provided by core ML tools, and then I can explain it briefly. Plagiarization. Okay, yeah. Plagiarization clusters the floating point weight to reduce the redundancy. And the linear quantization reduces the parameter precision, so making the model lighter. And the pruning. Yeah. It's not working, yeah. Okay, yeah. Pruning is removes unnecessary parameters to enhance efficiency. So first, plagiarization. This is neither complicated or intimidating. It's kind of easy, and I can explain. Here is like 12 weights, right? 12 values. And then we group similar numbers into clusters. See the color like blue, like negative 2.3, negative 2.5, negative 2.3. The average is going to be negative 2.4, right? And then you cluster them. And then what it does is you get the average of each cluster and then save it. You create the lookup table, LUT, the lookup table with the 4 cluster labeled 0 to 3, and then you save it in. And then you just label the mapping, right? And then what we do is to replace original values with the corresponding cluster average. That's easy, right? This is basically how does plagiarization works. But the thing is, like, you lose the details, right? Precisions, right? So that's what we have to take. There's just always trade-off. So what is next? We have 4 clusters, which means the precision is dropped to 2 bits, 2 to the 4, right? 2 to the 2 is 4. So, but originally it was 12 times 16, so 192 bits, which is 24 bytes. But like it dropped to the only 24 bits, which is 4 bytes, right? It's reduced by 8 times. This is how plagiarization works. But the thing is, so originally, I skipped too much. Yeah, and then what if you probably wondering like, hey Jason, like I'd like to drop the precision like even 1 bit, even more compression. Like, yes, you can. You probably can do, but if you do that, the llama probably look like this, right? So meaning that the model becomes too imprecise to generate the meaningful inferences. So back to plagiarization. So every optimization techniques comes with the granularity, which means what I just explained you is just the basic techniques, right? But there's the granularity that you have to there's core ML tools provides the different options for your situations. So granularity basically is an important concept. It determines how finely we apply the lookup tables when compressing model weights. So per tensor, I just explained you. And the per group channel, this is supported from the Mexacquire as well. So this method applies the lookup tables to group channel and improving accuracy and maintaining compression. So let's skip this part. Okay, so there's even more options like this. Okay, and next quantization. For those who are interested in like all those techniques, probably look it up at home. And quantization, let me explain you. This is also known as affine quantization. It's a basic, the linear quantization, the most basic. Let's focus on the key idea. Originally, we have a 16 floating points weight, right? There's a 16. Yeah, each weight is a 16, I mean. And then after quantization, these weights converted to 8-bit integer. You see that? You see the scale. Quantization maps weights into the 8-bit integer range, you know, negative 127 to 128 to 258, 256, right? So you basically just scale them, and then you reduce the size of it by converting the types of the tensor type. This is how quantization works, and also quantization also comes with the granularity. So tensor, channels, blocks, and you know, like per out channel for the second one. And then we have to, yeah, and also the third one is that we share the cross blocks of the values. And then we have a granularity we can use, they provide. And also we are going to talk about the pruning, the last one. The simply saying pruning just removes near zero value, you know, just pruning. Just whatever value near zero, like 0.1, 0.3, they just replace with zero. You know, we don't consider those values. Okay, and also this comes with the granularity and then block sparsity that I used before when I show you the llama conversion. And last, the pruning can be also combined with the other techniques. Like I showed you 3 techniques, right? But the pruning with polarization or pruning with quantization, this combination helps to maintain the performance and significantly reducing the sizes. Okay, that concludes my keynotes. I know today's topic kind of complex, also I speak a little bit fast. Sorry about that. I truly appreciate for your dedication today. And this is not all, actually. Today I just discussed about the what and how, right? Now I'd like to encourage you guys to think about the why. We never think about the why sometimes. We just do it, just for fun or because I can do it, or some people try to show off, you know, for many other reasons, right? But why we have to do this? There's so many knowledges out there, right? So we have to think about it that way. Why should I optimize the model? Like, why do I want to build my own model? Or maybe like, why, you know, should I use a lightweight LLMs, you know, to develop the reg system with those kind of like agent, right? So, but also like LM Studio, Llama, there's so many different type of the frameworks and libraries that we can use. But why we have to just convert, you know, into the ML package, you know? There's too much work, right? But we have to think about the why. And also, these questions spark meaningful discussions and inspire impactful distribution to the machine learning ecosystem. This is what I prepare for you today, prepare for you guys today. And last but not least, I really appreciate for the event organizer. And also, yeah, I want to express my gratitude to today's special guest, Eun-young of the Think Swift, KWC. I really appreciate for you, encouraging and support. And the last 2 years from now, I give my first major speech at KWC, the Korea's largest Apple development conferences. And that experience really helped me to grow as a speaker and to leading me to where I am today. I really appreciate for you guys. And yeah, also here is my LinkedIn and then social media. If you connect to my LinkedIn and you can come up with some other questions later on, probably you can send me direct message. I can answer you, and then we can discuss about the, you know, the machine learning ecosystem, or yeah, any like techniques related to machine learning or iOS. Okay, thank you guys. Appreciate it.
Thank you. Thanks, Jason.